Hello there, welcome back to Science Terminology. Today we're going to be talking about electricity and magnetism, which are two intertwined parts of nature. So that means they're connected. So we're going to talk about why they're connected a little bit and what that means. So to start us off here, I'm going to move myself over to the corner here, and then here we go. So definitions. Well, electricity, right, is just the set of physical phenomena that are associated with the presence and motion of things with electrical charge. So anything that has an electrical charge, any type of matter that moves, that has electrical charge, that's electricity. Um, the matter oftentimes associated with this electricity is the subatomic particle, an electron, right? Those electrons are charged and they're able to move around. So they are usually the things that the things that cause electricity. And then the electrical charge can be either positive or negative, and these charges can create electrical fields. Magnetism, on the other hand, right, is another type of physical phenomena that are associated with magnetic fields. And magnetism occurs because of these magnetic fields. So these magnetic fields create the phenomena of magnetism. And all substances can exhibit some form of magnetism. However, there are some substances that are more prone to it, like metals, and especially iron metals. They have the ability to be magnetic the easiest. Let's talk a little bit more about electricity. Electricity has been known for a long time. As far back as almost 3000 BC, there are records of like shocks in Egypt and stuff like that. So we've known about electricity for a long time. There have been a lot of scientists who have contributed to our understanding of electricity. For instance, William Gilbert distinguished magnetism from electricity because for a while we thought they were the same thing. Then he distinguished that they were slightly different. Ben Franklin determined that lightning was electricity. So a long time we didn't know that's what lightning was, and then we were like, it is electricity. And he did that with his kite experiment. If you went to elementary school, you'd know that one. Alessandro Volta created a battery, which means that he could generate electricity with a voltaic cell. Oersted and Ampere recognized that there's a thing called electromagnetism, which is where you get magnetism from electricity. George Ohm mathematically analyzed circuits, and then there are many others who also contributed in different ways, like Hertz and Einstein, Edison, Bell, and Tesla, just to name a few. There's tons of people who have made big strides in the field of electricity. Like I said earlier, electricity is just the movement of charged particles. So those charged particles that move, right, are usually electrons. This is easiest to do in metals because they have what's called the sea of electrons. Metals are basically just a bunch of blocked together nuclei, and the electrons can flow freely between all those different nuclei, which makes it easier for those electrons to move, which is why they conduct electricity so well. And then electricity, like I mentioned as well, also creates a field of energy called electric field. So if you've ever been close to like a really powerful electrical source and you felt kind of this like energy or this force pushing against you, that's an electrical field. Just so you know what that is. Now to talk a little bit more about magnetism. Magnetism was first seriously studied by William Gilbert, who I mentioned earlier, and he's from England. And when he was studying magnetism, he figured out that the Earth is actually a weak magnet, and which is the truth, right? The Earth has a very weak magnetic field, and that's why compasses work, because the compass needle can point along the magnetic field of the Earth. Magnetism has been known about for much longer, right? Ancient people knew that lodestones or magnetite could attract iron to them, so we've known about this force for a long time. Okay, so it's not something necessarily new. We do know about it. All materials can show some form of magnetism. Getting them to do that, though, is very difficult. Some things, right, just aren't very open to magnetism, but you can do it. Magnetic things create magnetic fields, which are just highly connected to electric fields. Those fields are generally connected to each other. And metals, like I said, are the easiest to magnetize, especially iron, which can be naturally magnetic, right? Magnemite and the lodestone is a type of iron. It's Fe2O3. So that's a naturally magnetic material. Now, electromagnetism, like I said, these two things are connected, and we kind of started to figure this out when Maxwell started making experiments with both of them. And he showed that interactions of positive and negative charges were mediated by one force. And then Hans Christian Ørsted furthered this idea by realizing that electric fields disturb magnetic objects. Basically, he was messing with these big electric cables, and when he turned the battery on, a compass needle would shift towards the electric coil that he was working with, which basically, in his mind, proved that that this electric field that was being generated by the electricity flowing through the coil was also creating a magnetic field. So that means that they are connected in some way. So electromagnetism is just kind of is turns out, right, after all this posturing and figuring it out, turns out it's one of our four fundamental forces that physicists use to describe the universe. And it's responsible for basically everything above the nuclear level we encounter in our daily life outside of gravity, right? So anything, any kind of interaction or atomic interaction that you've interacted with as a living thing has basically been some form of electromagnetism, which is pretty cool to think about, right? That this force has such an impactful um, part of your life with you're not really thinking about it at all. And these electromagnetic fields are composed of perpendicular electric and magnetic fields. So basically, you can think about it like this: if this is your electric field going like this way, right, your magnetic field is going to be on top of it like this, or well inside of it. So it'll be like that in it. So it's kind of like a plus sign moving through space. That's what an electromagnetic field is. That's how I think about it, at least. Now, because of these waves that are both electric and magnetic, we have what's called the electromagnetic spectrum, because there's a huge range of electromagnetic waves that can be produced by different various things. And so there's one type of electromagnetic wave that we can actually see, right? Visible light is an electromagnetic wave, so everything that you can see is being caused by some sort of electromagnetic wave, or an EM wave, as people call it in the shortened way. And electromagnetic waves have also been utilized for all sorts of different things, and you'll see what as we go through here, because I'm going to give you some examples. So here is the electromagnetic spectrum, and as you can see, there's lots of different types. On the top here, we have wavelength, so how spread out the wave is, right? How much it takes to go through one cycle of the wave, and then the frequency, which is how many waves go through in a certain amount of time. Now, the biggest waves are radio waves. Those are the ones that we use for Wi-Fi, for cell phones, for TV, for radio. All those things are radio waves. So radio waves are utilized for us to transmit messages and stuff like that. Microwaves we use to cook food, but we can also use it for other various things. Then there's the infrared, which you might have seen like a war movie where with the infrared goggles. Infrared has a high amount of heat associated with it, so you can read heat signatures using it. And then right here is where visible light is. So this section here is the electromagnetic spectrum that we can see. All the color that you've ever seen in the entire world is in this little part of this ginormous spectrum of waves. Follow that up with UV light or ultraviolet, right? That's the kind that gets you tanned and can cause skin cancer. And then we've got X-rays, which we use in the medical field, and then gamma rays, which are something that we also kind of use in gamma. We use that in the medical field. We use it to kill cancer. We use it for other sorts of things. So we use it to sterilize medical equipment, stuff like that. So it's also released by like planets, right? So it's a big one, right? It's kind of important. Thank you so much for watching this video about the electromagnetic spectrum. Hope you are in electricity and magnetism. Hope you learned something and it's piqued your interest in this topic of physics. Next time we'll do another topic of science-related stuff. It'll be exciting. Thanks again for watching. I can't wait to see you next time for another scientific terminology video. Bye.